Now, this is an incredibly powerful strategy. It can be used to turn horribly complicated questions into incredibly quick questions. A friend of mine once used it in a job interview. Okay, and in fact, I'll first kick off my explanation by telling you the problem that he got in his job interview. Okay, now as I describe it, I'll just do the classic thing of drawing a diagram just to get our heads around it. He got told, imagine there's a water jug. Imagine there's a milk jug. The water jug obviously has water in it, which I'll shade in. The milk jug obviously doesn't. Now, you take some of the water and you put it in the milk jug. And then you mix it around, and then whatever amount you put in there, you now put it back. Okay, so I hope you all agree there's some milk in the water jug, and there's also some water in the milk jug. Okay, the question my friend got asked him to compare those two amounts. So it's multiple choice out of 3. Is there more milk in the water jug than water in the milk jug? That's option 1. More milk in the water jug than water in the milk jug, or are they equal? Now, if you're not sitting there going, what, then there's something wrong with you. Okay, and I certainly did not envy him in having to answer that for a job interview. Okay, but in fact this question can be very, very easily solved by using the extreme case strategy. The extreme case strategy invites you to notice any situation where a detail is missing and you are very sure that it could not be worked out. Not even the smartest person in the world could work out how much milk there was in that scenario just then. Not even the smartest person in the world could tell you how much water there was, because I literally mentioned nothing about the actual quantities. So what you do in this strategy is you just make up a figure. And you make up a convenient figure, which is often an extreme figure. Okay? Now, I'll just make up a nice convenient figure initially. We're going to have, let's say, 4 units in the water, and then 4 units in the milk. So 4 grid squares is going to be a unit. Okay, now what extreme case? Remember, we have to move some over there. What's the most extreme thing you could do? It's actually 2 extremes. Move all of it, or move none of it. Okay? Now, let's imagine moving all of it. So this is now empty, and this is now completely full. And I'm now going to show it being mixed around, which I can't really very accurately show, but I'm not going to just put the black on top of the white. I'm going to imagine they're like mixed together. Okay? Now, I just moved 4 units, so I'm going to move 4 units back. So how much white is what it was originally black? 2. How much black is what was originally white? 2. So it's equal. Okay? Alternatively, just imagine moving none. So how much water is in the milk jug? None. How much milk is in the water jug? None. So they're equal. Okay, I'll give you another example. This is where I first heard of this strategy when I was at school. Imagine you have like a apple or something, and you kind of burrow through it. I think that's called coring the apple or something. And imagine you core through the apple so that this is kind of a 2-dimensional diagram of it. And imagine you core through the apple so that it now stands 6 centimeters on the table. So if you hadn't cored it, it would have been bigger than 6, because the 6 is from the flat top edge to the flat bottom edge. Just to make sure you understand what I'm talking about, if you had an absolutely tiny hole, then it would basically still look like an apple, just with this little pinhole through it. If you basically cut a huge amount out of it, it would look like a ring. Like if you just take any ring on your finger, you can imagine that used to be a sphere, it's just they took a hell of a lot out of it. Okay? Now the question is, what's the volume of that ring? Now that's hard because you don't have any formulas for the volume of a ring. So use the extreme case strategy. So pick an amount for how much got cut out. Now what would be the easiest to work with? None. None. Okay, if none gets cut out, that is the diagram. And what's the radius? And that's a sphere. What's the radius of that sphere? 3. So the volume is 4/3 3 cubed. And that's the answer. Now, there's some pretty advanced uses of it, but you can use it in all sorts of contexts, okay? So let's just say something like I don't know, let's say there's a school, 40% of the students are boys, 20% of the boys play rugby, etc., etc., etc. Okay? Now, there are so many percentages flying around here, it can get confusing. Just make up a figure. And make up a nice big figure where it'll be easy to take percentages of. So let's say like 1,000. So how many boys are there? If there are 1,000 kids, there are 400 boys, which means there are 600 girls. Yeah? 20% of the boys play rugby. What's that? 80? Etc., etc. It becomes so much easier when you just make up a figure. Now, don't overuse this, girls. You can only make up a figure if you're sure that you can't work it out some other way. But with experience, you'll get the hang of that. Okay? So that's the extreme case strategy. There was also the last, I think row 84 was naming, stating, and equating. There's already a video on that. The first naming, stating, and equating question is hard. Okay? But it's doable. Okay, so let's go back to the room and get cracking.